All right, so this lesson is over surface area of cylinders. So again, we have two different types of surface areas. We've got total and lateral. Total surface area is the sum of all the area of the surfaces of a solid. And the area of the curved surface, not including the base, is what we call the lateral. So you have two formulas here. One is the total surface area, and it's 2 pi r squared plus 2 pi r h. We'll talk about what that means in a minute. And then lateral surface area is 2 pi r h. Please remember that if the diameter is given, you have to find the radius first. So we're going to look at this example of this cylinder, and we're going to take it apart to look at its net. When you take it apart to look at its net, notice that this curved surface actually becomes a rectangle. And we know how to find the area of a rectangle because we can do length times width, or base times height. Now, if you imagine this cylinder folding back up, this circle would go here. And imagine that this piece would wrap around this piece. So this right here would end up wrapping all the way around this. And when we wrap all the way around a circle, that's what we call circumference. So this length right here that we were just talking about, right here, is actually going to be the circumference of this circle. Well, how do you find the circumference? 2 times pi times r. In this case, r is 3. There's your pi, and there's the 2. So when we look at our formula to find the lateral surface area, notice that it's 2 pi r. Okay? So forget about the h for a second. It's 2 pi r, and then that h is the height because we're doing length times width. So that's that part of the formula. And then notice when we move to total surface area, here's our 2 pi r h again. That's our lateral part. But then we have 2 pi r squared. If you think about it, pi r squared is the area of a circle. Well, what's our base? A circle. And how many are there? 2. So that's why it's 2 pi r squared. Okay? So now that you know where the formula comes from, we're going to use those formulas. So here's our picture again. Our lateral surface area formula is 2 pi r h. And just so we don't have to use a calculator right now and to make our math a little bit easier, I am going to do this with 3, but I believe the key that we posted has it done with 3.14. So just be prepared to do it whichever way. So 2 times 3, our radius is also 3, and the height of the cylinder is 8. So 2 times 3 is 6, times 3 is 6 times 3 is 18, and then 18 times 8 is 144. Okay? And that's going to be units squared because we are talking about area. Now our total surface area is going to be 2 pi r h, which we already found, plus 2 pi r squared, which I don't know yet. So I'm going to plug in 3 for pi, r is my 3 is my radius. I need to do my square first. This is why we learned order of operations. My square first is 9. 3 times 3. Remember, that's not 3 times 2. And then I can do this in any order. 2 times 3 is 6. 6 times 9 is 54. And when I add those two together, it's going to give me 198 units squared, again, because we're talking about area. All right, on the next one, we're doing the exact same thing. We're doing lateral surface area, which is 2 pi r h. I'm going to plug in 3. R is 1. Height is 7. So 2 times 3 times 1 times 7. 2 times 3 is 6 times 7 is 42 units squared. Total surface area is 2 pi r h plus 2 pi r squared. I've already found my lateral surface area. Now I just need to plug in pi, 3, and the radius is 1. So 42, 1 squared is just 1. So I'm adding 6 to 42, which makes 48 units squared. All right? If you want we're going to skip this example because it's the same thing that we just did on the last two. If you want to see it worked out, remember that that is also posted on Edmodo, so you can go and look at it there. This example we are going to work because it does have a decimal, so I just want to make sure that you guys get the calculations right. It's 2 pi RH, so that's 2 times 3 times the radius, which is 1.8, times h, which is 4. So because this is all multiplication, please remember that you can do multiplication in any order. So I'm going to multiply all my whole numbers first. That way I only have to deal with the decimal once. So 2 times 3 is 6, and 6 times 4 is 24. So now I'm multiplying 24 times 1.8. Please remember that you multiply decimals with whole numbers, just like the decimal doesn't exist. You just count how many decimal places there are. So 4 times 8 is 32. This is 16 plus 3 is 19. Scratch it out. Put your placeholder. That's a 4 and a 2. That's 2, 13, carry my 1, so that's going to give me 4. And don't forget to put that decimal place back in. It's 43.2 units squared. Oop, this one's not units, it's meters. So meters squared. My total surface area, again, is 2 pi RH, and it is always really good practice to write your formula down. So this part, I've already figured it out, 43.2 plus 2 times 3 times my radius was 1.8 squared. So I'm going to go over the side and multiply 1.8 times 1.8. Please remember there's 2 decimal places. Oops. Forgot my placeholder. And there are 2 decimal places. So I get 43.2 plus 2 times 3 times 3.24. Now again, I'm going to do my multiplication of the whole numbers first so that I only have to deal with that decimal one time. So 3.24 times 6 is 24, 12, 14, 18, 19, and again there's 2 decimal places. And now I need to add these 2 numbers together. So this is giving us really good practice with decimal operations. So we've got 4 and 6, carry down my decimal. That's 12, that's 4, 5, and 6. So that's going to be 62.64 meters squared. Okay. So same exact process, it's just dealing with decimals. Sometimes you'll deal with fractions, sometimes you'll deal with decimals, sometimes with whole numbers. So hopefully our test wouldn't be so nasty as to give you this and expect you to use 3.14 for pi, but it is a possibility, so just remember that you can always do some estimating to figure out what your best answer might be. All right, so this is actually an old tax item, but it is still a pretty good problem, so we're going to use it. It says, for small paving jobs, a contractor uses a roller pushed by a worker. Now, if you notice, that roller is in the shape of a cylinder. We want to know, to the nearest square inch, we are rounding, what is the area of the pavement with which the surface area of the roller will come into contact. So if you think about it, look at how this guy's walking. As he walks, this part ends up being rolled out. Now, what is that that's rolling it? It's the part around the center here, which is your lateral surface area. So they're asking us to do 2 pi RH, and we're only doing 1 complete rotations, and then we're going to do 20 complete rotations. So I'm going to use 3 since it did say I could round, and h is 30. So 2 times 3 is 6, 6 times 8 is 48, and 48 times 30 is 1,440. This is going to be inches squared. Now for my next question, it wanted that out of 20 rotations, so I'm going to need to multiply that by 20. So that's going to be 28,800 inches squared. All right, so please complete the next few pages in your practice workbook, and we will talk about them tomorrow.